Good morning once again from Mission Control Houston. You're looking at the Dulles Flight Control Room as we continue our ongoing coverage of the Orbital ATK CRS-9 mission. The Cygnus spacecraft is in orbit right now following a successful launch atop the Antares vehicle. And we're back now for the final stage of this preliminary day. That's the solar array deployment. The two ultra-flex solar arrays on the Cygnus spacecraft still folded up in their pre-launch configuration against the vehicle right now, and over the next 30 minutes or so should start to unfurl. Those solar arrays providing power to all of the systems on board the uncrewed cargo craft, currently carting over 7,400 pounds of supplies onward towards the International Space Station. It's in its preliminary orbit, just a little over 120 miles over the Earth's surface, already circling at just about 17,000 miles an hour. It lifted off on top of an Antares rocket successfully this morning and is, as we said, now circling. Here's a replay of that launch, which the liftoff coming right on time at the end of the window at 4:44 and 6 seconds Eastern Time, 3:44 and 6 seconds Central. The first stage powering the Antares rocket across the night sky through some cloud cover as there was some inclement weather in the area that up until just a little while prior to the launch was actually in some violation, but they were able to wait until that weather was out of the way, and they were able to get Antares successfully off the ground. The whole ride to orbit is over in just about 9 minutes. The powerful first stage burning liquid fuel, delivering power to the Antares rocket for the first 2 minutes or so, ultimately dropping away before the second stage using a solid rocket motor puts Cygnus into its initial orbit. But again, this launch, no issues tracked with the vehicle, either the Antares rocket or Cygnus up until the launch, and all signs pointing to a very successful launch this morning. But with the launch in the books, we're now just going to stand by as the flight control team out at Dulles that we're looking in on now, overseeing systems on board the Cygnus, dubbed the SS J.R. Thompson, following the tradition for Orbital ATK to name the Cygnus spacecraft for individuals who helped have an impact on our nation's spaceflight programs. For the OA-9 mission, they announced the spacecraft was named after J.R. Thompson. He was a leader in the aerospace industry and a member of the Orbital ATK family, holding positions at NASA, down at the Marshall Space Flight Center, and at Orbital Sciences, celebrating his life with this spacecraft. So the SSJR Thompson in space, and we are going to stand by now for that solar array deployment. We're expecting the command to actually deploy the solar arrays to come shortly before the top of the hour, so we'll listen in with the teams, and we'll update you as we get the milestones checked out. It takes about 30 minutes or so for the solar arrays to unfurl, and once they are confirmed in a good spot, we'll be wrapped up with this morning's coverage, and Cygnus will be well on its way towards the International Space Station. So with Cygnus on its way, it's carrying about 7,400 pounds of cargo for the Expedition 55 crew. On board, over 2,000 pounds of that is science experiments, bound for work by those 6 individuals over the next several weeks. Just a couple of highlights of the stuff that launched on board while we wait for this solar array process to begin. One of which actually taking a page from a centuries-old navigation tool, actually flying a physical sextant for testing on board the International Space Station. For many centuries, sailors across the open oceans use sextants, which have an optical sight to help take precise angles using the stars and other heavenly bodies for measurements across land or sea. Actually, some of the early NASA missions also used this same technology, starting off with NASA's Gemini missions, and they actually built one into the Apollo vehicles, just in case they were to lose communications, they could still navigate. Jim Lovell demonstrating that back on the Apollo 8 mission. And so they'll actually be using a handheld device for emergency navigation. They're going to be testing that out on the space station. That could potentially come into play for deep space missions as we get ready to travel far beyond our planet, returning to the vicinity and down to the moon and eventually onto Mars. The ability to get those angles between moons and planets could be an option to find their way home for astronauts, should communications or computers or anything like that eventually go down. Also making the trip up, a biological experiment called the Biomolecule Extraction and Sequencing Technology, or BEST for short, and that's continuing a lot of the work that's been going on board in gene sequencing and other biological studies, using new hardware that miniaturizes a lot of those processes that used to require entire laboratories, now about the size of a thumb drive actually. A previous experiment, Genes in Space 3, was actually the first in-flight identification that had an astronaut take a sample of just a swab of surface on the station and able to sequence and identify bacteria. And this is going to take it one step further, actually identifying any unknown microbial organisms using a process that actually has way less preparation than some of the traditional techniques that actually require growing a culture from a sample, which can take a much longer period of time. This type of technology really important and really starting to mature now on board the International Space Station, as it can allow astronauts to actively identify biological organisms on their spacecraft. So that could have huge implications in helping to keep them in a safe and healthy working environment, but also in the very far off future, potentially identifying biological matter on far-flung planets or any other exploration destination for human explorers in the future. Being able to do that without a full laboratory be a hugely useful tool. And then one of the pretty cool experiments that's flying up today also comes with a pretty cool name, the Cold Atom Laboratory, also known as CAL. And it's a fundamental physics experiment that's going to allow scientists to actually probe the building blocks of nature, the stuff that makes up everything from the galaxies that we see in the night sky to individual people. The Cold Atom Laboratory, which is going to be installed on the station, produces clouds of ultra-cold atoms, and when they're in that state, they're called Bose-Einstein condensates, or BECs. And when they actually get to this temperature, they behave less like particles and more like waves. And once they're on the International Space Station, as they're free, as all of the experiments up there are, from the pull of gravity due to the microgravity environment on board, scientists will actually be able to observe the particles when they're in this state for way longer than what they're able to actually see here on Earth. The temperature in the Cold Atom Laboratory is going to be chilled to about 10 billionths of a degree above absolute zero. And just to give you an idea of how cold that is, that's about 10 billion times colder than the average temperature of deep space, which is usually about 3 Kelvin, 0 Kelvin being absolute zero. And so that's just a couple of the research investigations packed away inside Cygnus, destined for the International Space Station. Again, it's set to arrive on May 24th, this Thursday. And once there, it's going to get grappled by the crew on board. Scott Tingle, NASA astronaut, is going to be prime for actually reaching out with the Canadarm2 robotic arm and grabbing Cygnus while it's only about 30 feet away from the station. He's going to be backed up by Ricky Arnold and Drew Feustel, his fellow NASA astronauts on board, who will be providing support and monitoring Cygnus during its final approach. After it's captured, they'll hand over control to the teams down here on the ground, who will ultimately maneuver Cygnus and install it on the Earth-facing port of the Unity module, also known as Node 1. then it'll be up to the crew to get the hatch open and begin unloading the more than 3 tons of cargo on board. For now, though, in the next couple of minutes, we'll stand by. They'll get ready to send the command to begin this solar array deployment. It's all timed around when Cygnus is entering into an orbital sunrise. And then after they give the command, it'll take a little bit, and then the solar arrays will actually start to deploy. Once that process starts, it's about 20 to 30 minutes until they're completely unfurled. And then Cygnus will be in its orbital configuration and begin its chase down of the International Space Station. It'll execute a series of what's known as delta velocity burns, or DV burns for short, for the teams here. And those are periodic timed firing of the engine on the service module of the Cygnus vehicle. It's going to gradually raise its orbit over the next several days, as its preliminary orbit at about 120 miles. It's going to raise that up to the roughly 250 miles over the Earth that the station flies at, ultimately showing up on Thursday morning. For now, though, we'll go ahead and stand by, and should be hearing some chatter, hopefully, that the solar array deployment has begun. So we'll go ahead and stand by for that. And we're continuing to look in on the Orbital ATK team out at Dulles. This is one of 2 control rooms that they've had in operation this morning. The control room at Wallops, its job done with Antares delivering Cygnus into orbit. And the team out at Dulles now overseeing the Cygnus vehicle during its flight, and they'll be liaising with the teams here in Mission Control Houston throughout Cygnus's mission, obviously overseeing the vehicle during its flight to the station, and then also providing any support necessary while the vehicle is docked to the station, where it's scheduled to remain throughout July, ultimately being released on July 15th on the current schedule. And this is Mission Control Houston standing by. We should pretty soon get confirmation of the start of the deployment, or at least the command being sent to begin the deployment. Once we hear that, we'll update you. Again, the command will be given, and then it'll be about 15 minutes or so until the actual deployment of the solar arrays begins. That whole process takes about another 20 minutes. And then the solar arrays on Cygnus will be out. The vehicle will be on its way to the station. And hearing from the orbital team, go to deploy, so we'll stand by for confirmation that the command has been given. And again, this is Mission Control Houston, still getting a look into the Dulles flight control room. We're the flight controllers for Orbital ATK controlling the Cygnus vehicle. We're still standing by for the start of that solar array deployment, and the whole process takes about 30 minutes or so. But this the last major milestone until Orbital begins its chase down of the station with the series of delta velocity burns to gradually raise its orbit, catching up to the International Space Station. So we'll just continue to stand by and update you as we get some new information. And this is Mission Control Houston again, still standing by for confirmation that the solar array deploy is underway. And hearing a quick update from the team out in Dulles, solar array deploy should start in the next couple of minutes. Again, once we get confirmation that the process has started, we'll let you know. It'll take about 20 minutes or so for the arrays to fully deploy. After it is started, first the command given, and then after about 10 minutes or so, the process beginning. So all told, about 30 minutes to get these arrays out. And once those are out, Cygnus will be in a great configuration to begin executing its series of burns, several of which are planned throughout the rest of today. But Cygnus will be executing all of these burns to ultimately link up with the International Space Station this coming Thursday on May 24th. It's going to arrive in the early morning hours Central Time, at which point the crew on board will be poised at the controls of the robotic workstation and ready to grapple the vehicle using the Canadarm2 robotic arm. And then after that, it'll be handed off down here. We'll be bringing you live coverage of all of that on Thursday, starting at 2:45 a.m. Central Time, 3:45 a.m. Eastern. The capture is scheduled to come right at about 4:20 a.m. Central, 5:20 a.m. Eastern. And after that, again, they'll hand over control down to the ground. We'll then orient Cygnus to its berthing attitude, and then attach it to the Earth-facing port of Node 1, also known as the Unity module. And again, this is Mission Control Houston, still standing by for the start of the solar array deploy, expecting it to come any moment now. And once we get a confirmation, we'll go ahead and update you. But still looking in on the Orbital ATK team there out in Dulles, overseeing operations on the Cygnus vehicle now in space. And so we'll just continue to stand by that solar array deploy coming soon. And this is Mission Control Houston. The solar array deployment is in progress. Continuing to get a look at the Orbital ATK team out there at Dulles who are overseeing the operation and going to be flying Cygnus over the next several days. So the solar array is deploying. This whole process takes about 20 to 30 minutes, so we'll continue to stand by and wait for confirmation that they have deployed successfully. And then with that, Cygnus will be on its way. So the deployment in progress. We'll continue to stand by. And this is Mission Control Houston, 1 down, 1 to go. Wing 1 confirmed to be unfurled by the team out there at the Orbital Mission Control Center in Dulles, Virginia. Standing by for confirmation on the second wing. And confirmation now coming in, Wing 2 unfurled. So both solar arrays now out. We'll hang out for just a few moments more and see if we can get a confirmation that they're drawing good power. But good signs from the Orbital ATK team out there at Dulles. Both arrays now unfurled on the Cygnus cargo craft. Orbital ATK's 9th resupply flight to the station in orbit with solar arrays out. And so again, the solar arrays successfully deployed on the Cygnus vehicle. So with both solar arrays out, now positioned and ready to start harnessing energy from the sun for the systems on board the orbiting spacecraft, as it's now going to begin its chase down of the International Space Station. With the solar arrays out, it's now going to execute a series of burns over the next couple of days, ultimately arriving at the station on Thursday. And just to recap those times again for you real quick, Cygnus set to arrive on Thursday, May 24th. The coverage will begin here on NASA TV at 2:45 a.m. Central, 3:45 a.m. Eastern for a capture by the Expedition 55 crew at 4:20 a.m. Central, 5:20 a.m. Eastern. We'll then break for a little while, coming back on the air for the berthing coverage at about 7:30 a.m. Eastern, 6:30 a.m. or rather 7:30. So with that, Cygnus in orbit, 2 good solar arrays deployed, going to begin its chase down now of the station. That'll wrap up our live coverage of the beginning of this Orbital ATK's 9th resupply mission to the International Space Station. Be sure to stick around. We'll be bringing you our post-launch news conference from out there at Wallops coming up soon. And that'll close out all of our activities for the day. So thanks for waking up early and joining us today as we sent Cygnus on its way. And be sure to tune back in on Thursday as it arrives at the International Space Station. For now, though, we're going to go ahead and sign off. This is Mission Control Houston.